Hi Jenna and anyone else who may want to see number 7 and 8 or 7 or 8. So I'm gonna go ahead and go over 7 and 8 on that exam to practice. Let me open it up. Okay, where is 7? Okay, let me do 8 first. It looks shorter. It just looks shorter. I'll do 8 first. Okay, so number 8. Let me put it over here. If $12,450 is invested in an account that pays interest compounded continuously. As soon as you see that part, as soon as you read, oh, this is compounded continuously problem, I want you to remember that the formula for this is A equals P times E raised to the RT power. So that yellow or the orange highlighted part told me that I will need to use this formula. And you know what they told us over here is the principal so far. How much is being invested? 12,450. This is the initial investment amount. So you're going to plug that in right here at P. How long will it take to grow? Will it take what? Was there more parts to this that I cut off? Let me see. Oh no, it wasn't. Just, I guess, will the money that our original investment take to grow to $250,000? All right. Now the things about the $1 million and stuff, I don't really use those numbers so often. So I just want to make sure that I have enough zeros after it. So you give me 1 second. I'm gonna go ahead and type in 1 million. Million has 6 zeros. 1, 2, 3, 4, 5, 6. And I'm gonna divide that by quarter, or divide that by 4 to make it 250,000. All right. And I should have 2,500,000. So I need 25 at 4 zeros. Okay, that's what I want to have at the end of this investment period. So let's put that down as A. $250,000 is the goal amount, but we are starting with 12,450. All right, let's write down what else we know. E is just a constant, so you write down the E, but we're raising that to a rate of, what's the rate? Well, 3.65% in decimal is 0.0365, so that's our R. 0.0365 times T, but T is unknown because we are asked to find how long will it take. So keep that as T. For step number 1, what do you do to both sides? We're going to divide both sides by 12,450. 12,450. Uh-oh. I apologize. 12,450. It's probably not a good idea to round our answer in the middle of a problem. So I'll just keep that big fraction the same. Maybe I can just take away these zeros, like divide top and bottom by 10. And I'll say the fraction is 25000 over 1245. And that is equal to e raised to the 0.0365t. And to bring that exponent down and also to cancel out that e, let us take natural log of both sides, okay? So here, take natural log of that fraction and take natural log of the right-hand side. What will happen is we will have that natural log of that big fraction the same on the left side, but what will happen? This exponential term, this exponent will come down to the front, right? Using the log property. So we will have 0.0365t, not anymore a small superscript, but just a term now, okay? It's not an exponent anymore. And then I was going to write down ln e, but What is natural log of e? That is just 1. So we don't have to write that down anymore because that's just multiplying this decimal t by 1. So that's just 1. So that's all. Now to solve for t, we just are one step away. Divide both sides by 0.0365. Divide both sides by 0.0365. So what is t? T is approximately whatever this is. So I'm going to go ahead and type that in so that we can give them an approximate number of years to for this investment to grow to be $250,000. Okay, so look, I'm going to type into my scientific calculator that I want them to know, tell me what natural log of 25,000 divided by 1,245. And we want to divide that natural log by that rate of 0.0365. And that comes out to be, approximately 82 years and 82.18 years. So that's going to be my final answer. 82.18 years. So that is how you would solve question number 8. Okay? So just setting it up, well, first got to recognize which formula we are using, plug in all the numbers that are given to us, and solve for t. So that's number 8. And now I think the next one was number 7. Let me go copy that. 7 looks so big. Oh no, it's just because of the picture. So I'm going to copy this down on another page. Alrighty, let's do this. The tortoise, isn't that turtle? But what's the difference? I guess these are the big guys, but I have hard time saying the word tortoise, so I'll just say turtle, okay? So the turtle population, P of T, in a square mile of the, I guess that's called Mojave Desert, right? Anyways, in this desert area, after T years can be approximated by this logistic equation. Look at this. The population will only grow to be 3,000 turtles in a square mile. That's that limit right there, right? Okay, so what are we doing? They want us to find P prime of 15. So T stands for years, right? So we're finding something that has to do with 15 years from now. 15 years from now. So, all right, let's find this. And then part B is asking us to interpret this in the context of the problem. So let me copy this down here so that we can find the answer first, and then we'll talk about what that number means to these turtles, okay? So that is our P of T. Now, we see a quotient. We can rewrite this as a, I'm just going to do a quotient rule because I think that's how a lot of us will just see this. This is 3,000 over 20 plus, this bottom part. So I'm going to use the quotient rule here, okay? So remember, quotient rule says if you want to take the derivative of f over g, I always start with the denominator. Denominator is going to be original denominator squared. The numerator, we start with g. Okay, so we write gf prime minus fg prime. So let's identify all our pieces. That's what I like to do. So I know f stands for the top of the fraction. So my pieces, f is 3,000. That's the top of the fraction right there, right? But what is the derivative of this constant 3,000? Well, f prime is just 0. So guess what? This part, first part right there, that's just going to become 0. Whatever g is, if you multiply something by 0, that's just going to be 0. So that term will just get canceled out. But anyways, let's go to G now. G is the original bottom of the fraction. So this whole thing. So I'll write down 20 plus 130 times e to the negative 0.214t. Now we have to take the derivative of this, and this is the new lesson in this chapter, right? Derivative of 20 is just 0, right? That's just going to give us 0, so I don't have to write that. But look, I need to multiply this coefficient of 130 with this coefficient in the exponent, okay? So, all right, hold on. Let me get that what that number is first. Those green numbers multiplied together. 130 times negative 0.214. That came out to be minus 27, negative 27.82. And then what you have to do is just copy down that exponential term above exactly the same. Apple pencil slow. E raised to the negative 0.214t. So that exponential term doesn't change. Alrighty, so I got all my quotient rule pieces laid out. I'm going to go ahead and put these together, okay? All right, hold on. Let me erase this highlight. So, P prime of t, using the quotient rule, will look like this. I need to have the original denominator squared. So, G squared. So you start with that. We write 20 plus 130 times e to the negative 0.214t in the parenthesis, and we're going to square this. So that's it for the denominator. Let's move to the top of the fraction. Top of the fraction, I have to say g times, okay, look, I'm going to have to do this times f prime. But now look, I was going to write the whole thing down. But if I multiply this thingy by 0, what's that going to be anyways? That's going to be 0. So do you mind if I don't write this at all? I mean, I don't want to write it. It's just multiplying by 0. So I will not write that first term because this gf prime, g times f prime, will just be 0. So I will skip that. All right, next, what's next after this green circle? The minus sign. So you write down the minus sign, and then I'm going to write f. F is 3,000. 3,000. And I'm multiplying this by g prime, which is this right here, okay? You know what? I don't want to write the whole thing. Let me try something. I'm going to just duplicate this down here. Looks beautiful. All right, but I'll put these in a parenthesis so that it's clear to me that I'm going to be multiplying. So P prime of t is equal to, I mean, it's very good as is. It's just that I do want to multiply those numerators. So the denominator stays the same. But you know what I'm trying to do is I'm just going to multiply this number times this number, okay? I'll just want to multiply those two. You give me 1 second. I'm going to get my calculator. So I will do negative 3,000 times negative 27.82. That came out to be a big number. Okay, that's a little too big. I'm worried. All right, but anyways, I think that's right. Okay, so 83,460 times, and I'm just going to go back to my paper, okay? E raised to the negative 0.214t. Now we found the derivative function, okay? That's how fast this turtle population is changing at any year t. They wanted, in part A, to find P prime of 15. So all we now need to do is plug in 15 into our answer. Ready? So let's do that. So P prime of 15 is equal to, I mean, everything will be the same, right? I'm just copy this down, but we're going to have to Don't erase the whole thing. We're gonna have to just replace the t with what? The t's will become 15. So look, I'm gonna plug in 15 here. And there's another t down in the denominator. So I'll change that t to 15. All right. And then I'm going to find out what that is. Okay. So open up a calculator again. Let's type this in. So we'll have 83,460 e to the negative 0.214 times 15. Go to the bottom of the fraction. We do parenthesis 20 plus 130 e raised to the negative 0.214 times 15, but don't forget to raise that entire denominator by to the second power. So what does that mean? So I got a number 5.28. Now I'm gonna go ahead and interpret. Simply they just wanted us to find p prime of 15, so we did find that. But let me go find the unit of this problem. We're talking about the number of turtles in a square mile in this desert after t years. So my answer with the unit, all right, you guys hold on, I'm going to write the unit. Go down here. I will say tortoise. Such a cute word, but how do I spell that mess? Tortoise. Tortoise. Okay. Per square mile per year. Okay. Positive number, right? So that means the turtle population is growing 15 years from now, and is growing as fast as about 5 turtles per square mile per year. And that's what you want to talk about in part B. What does this value represent in the context of the problem? Tell me that the turtle population is growing by how many turtles per square mile per year? 5.28 turtles per square mile per year at after 15 years. Okay, that's what we plug in. So those are the things that you want to include in your interpretation. I don't think I'll write that down, but that is how you would do number 7, finding the derivative using the quotient rule, plugging in the number to find the answer for part A, but just need to talk about what that number means in the context of the problem. So that concludes number 7 and number 8. If you need to see anything else before your exam 2, just email me, okay?